Okay, right. We are in the first question. We'll take exam paper. First question regarding the first transition enthalpy. Right. The element with the highest first transition enthalpy out of the following is right. So we have provided certain elements. These elements, second period and as well third period elements also available. These two are third period, other three second period element, right? There is a misconception. The second period elements having higher first transition energy in high value compared to third transition energy. In third period element, that is a misconception. Second higher first transition energy compared to third one, right? That is a misconception. Sometimes, right? This is the pattern actually, right? We have the black line one to indicate the transition energy of second period element. Even I have inserted for the third period element. It is very clearly you can observe the argon, right? Initial in magnesium, aluminium, silicon. These three are inserted to the graph, and these three. Okay. In this way, right? You can arrange for the graph or some other technique to find the answer. So in the graph, easily you can find the correct answer, right? To consider the value of chlorine is greater than that of carbon. Say carbon is certain period element, chlorine argon value is higher compared to carbon and boron, right? In the element lithium, beryllium, boron, carbon, the mean value for argon and chlorine is high. So you should be very careful to find the answers. Now, how are you going to get the answers, right? Clear answers. Carbon is provided, carbon is provided, nitrogen is provided, silicon is given in the answer, oxygen is here, and even phosphorus also present, right? So the correct answer should be nitrogen. In this way, you can find the answer, right? But this is the main work plan. Whenever they are asking first transition energy, you need a graph, which has to include second and third period element together. If you want this particular diagram, I can send you the WhatsApp group. Okay, right? By the point I'm going to show later. If you want anything, you can chat with the chat in the WhatsApp. Okay, that is the first question. Let's talk about the second one. Right. This question is talking about electron gaining energy. So gaining energy. What do you mean by electron gaining energy? Clearly, you have to understand regarding that. Ionization energy always is a positive value. We call endothermic, right? Endothermic into Luna. Endothermic and supply energy. To remove electron, supply energy. So we call always positive. You need to provide energy. When you come to electron gaining energy can be either plus or minus. What do you mean plus or minus? Can be either endothermic, you have to supply energy, or exothermic, you emit the energy. Right? These two possibilities are there. So carefully we have to understand which one emit the energy, which one absorb the energy, and the graph and the pattern. The ionization energy, you have a graph, you have a pattern. So on the pattern use panita, you have to find the answer. Similarly, we can plot a graph, right? Related to electron gaining energy. How are we going to do this part? Right? I will try to show a graph. In the graph, I want to I can send you right. Yeah, this is a graph actually. The position of chlorine and chlorine is here. This is group 17, and oxygen and sulfur group 16, position of chlorine. So initially try to understand what is this pattern. This is 0, right? We can mark it. This is 0. This particular value is negative. Mean exothermic. These elements, especially non-metals, right? Mark it. Okay. right? These are actually non-metals, especially non-metals. But here the electron is mean the energy is losing here, mean exothermic energy emits during the process. Above zero, the values are positive. Values are positive. So what we call endothermic, right? Endothermic. That way, we can arrange this graph. These are negative values, right? In the region we present negative value, exothermic. This region indicate the endothermic. So just a graph based on the data, right? Electron gaining energy data will use funny develop on a particular graph and the particular graph, right? Okay, just I'll try to mark the data, right? I'll try to. Okay, good. I'll try to explain so it's slow. இப்போ நாங்க இதுல படிக்கிறோம் பார்க்கிறோம் என்கிட்ட electron gaining energy தொடர்பாக we'll going to understand properly, right? Initially நாங்க discuss பண்ணினோம். Initially ionization energy discuss பண்ணினோம். Ionization energy discussionல very important thing is to use a graph. The graph வந்து includes second ionization energy, first ionization energy, second period as well third period. First ionization energy, second and third is included here, right? These are most convenient approach. Both graphs are together. Easily, if you can plot this graph, easily you can work out the issue, right? First ionization energy, quick and determine panel. Misconception in second always higher compared to third period element. That is a misconception. This is not true actually, right? This is the way the graph will be. So, right, I think you may clearly understand. Second point, we are talking about electron gaining energy. Actually, what do you mean by electron gaining energy, right? Say you have an element, the gaseous state, right? You have to supply electron, then will become a negative ion. In the process, electron gaining energy in the process the process one day, sometimes most willingly an electron can be gained. The chlorine or non-metals one willingly take the electron, right? After electron gain what happens? Energy emit so it can absorb. Both these possible, both possibilities are there. I will try to explain what is this process. Okay, we'll try to use this graph. Why, how it happens in the part a little bit. Okay, we'll try to discuss or understand this issue. Say you have a sodium atom. Sodium atom is present. 11 protons are there. 11 protons are there. Right? Electron configuration 281 and the okay, 281 and the okay. Right. If you want to put the electron in the track, right? If you want, right, say you don't have any electron, you don't have any electron. Okay, these are tracks. N is equal to 1, N is equal to 2, N is equal to 3. If you want to put an electron in the track, right, these are now 3 electrons, right? It is away from the nucleus. Nucleus is away, right? Nuclear attraction only in there. There is no such track. So, if you want to place this electron to the track, what is the thing you have to do? Already these are free electrons. Free electrons, it possesses energy. Now, in the plane, the very will jump. You have to provide energy. So then only the electron will be free, right? These electrons are being much more energy. If you want to keep this electron once again to the track, right? What is the thing you have to do? You have to lose the energy, isn't it? Lose the energy. Then this electron will come to this particular track. The energy one will loss electron lose panama. So with the energy lose panama, then only you can place the electron in the track. First point. If you want further go to inside tracks, still you have to lose the energy. Still you have to lose the energy. When it comes to very closer, has to lose much more heat or energy to come very closer to the nucleus of sodium. So this is the idea, right? After 2-3 ways we can think. When, for example, okay, like element like nitrogen or some other element, right, already has electrons, right? Some electrons are there. If you want an electron to keep in the track, if you are going to try to keep an electron in the track, right? Here there are two things occurs. One is the protons are there and electrons are there, right? This electron is there. This electron you are going to keep in the track. But one is there is a repulsion. Electron repulsion electron repulsion. Same time, this proton may attract the electron. Okay, attraction and repulsion both are there, right? One of value the other value become exceeded, right? For example, attraction right? Automatically this you can keep the electron. If the attraction is higher, you can keep the electron. The repulsion is higher, right? Easily you can't keep the electron in the track. Then that's a difficulty. You have to input certain amount of energy. Electron gaining energy become plus or minus. Mean exothermic, so endothermic energy. Supply one or sometimes it emit the energy. This is the basic idea about electron gaining energy. I think may understood a little bit, right? On the way, you have a difficulty to arrange this work. So what we can do is we can put even a graph, right? Other than the graph and draw up one shows a negative value, mean exothermic. Positively mean endothermic. Energy supply panel. Okay, now if a general non-metals group 17, 16 energy emit, right? Food emit chlorine, then chlorine. So the next one, group 15. If you come to group 15, you don't have a nitrogen here. You can only insert the phosphorus. The place of nitrogen is somewhere here, above zero. Above zero means it shows positive value. It is endothermic. Very clearly, you can understand nucleus, right? Electrons are there, right? Nitrogen is 7 protons, right? 2 5 electrons are there. In the 5 electron fact level, you have to keep the electron. There is a powerful repulsion, right, from this second electron. The electron very close to the nucleus are there. Powerful repulsion on work, right? This 2 electrons are there, right? The 5 electron track level, you have to keep the electron, right? When you come bring the electron toward this energy level, there is a powerful repulsion due to this particular inner electrons, right? And the inner electron the repulsion are there, right? That's a difficulty. Therefore, it will become a positive. That's the reason, right? Upper position of phosphorus is here. Then, what are the other elements, right? You can go to group 14, carbon and silicon. Position of carbon, silicon is. Furthermore, this one, group 13. What are the boron and aluminum? This is the pattern we chose, right? What is this then? Right, actually, this particular line belongs to group 1 element. This belongs to group 1 lithium and sodium. Group 1 right? So the group 1 element also shows. Okay, if you look the group 1 element, group 1 element the exothermic, it is a negative. Other negative positive and confused negative positive. Energy A, B, right? If energy also emitted, right? Heat emit energy emit we call negative. If energy is absorbed to become a B, this is we call plus value. Plus value energetically you learn why it will become a positive, negative, you will learn, right? Future the confusion I can support you a bit to understand why it is positive and negative. Say you have A, become D, right? 50 kilojoule internal energy. Right? The molecule having 50 kilojoule. It has 100 kilojoule, right? When it A converted to B, right? Energy of mean compound, if it increased, it will become 100 kilojoule, right? Delta H mean, right? Product energy you have to deduct the reactant energy. Product minus reactant, right? Product energy reactant energy deduct one, then you will be able to get a value that is plus value. It means this reaction has to absorb 50 kilojoule. Absorption under the positive value mean background is done. You can even think about regarding the negative value, how it is. Say the compound C become D, right? Say you have a 200 kilojoule, it become around 150 kilojoule. So it has a less than electricity. So always delta H is equal to, right? Delta H product minus delta H reactant. Simply we can write it. What is the value for the product? 150. What is the value for the reactant? 200. Therefore, answer is, right, that one minus 50 into the Bernoulli. This reaction we can call it as a 50 kilo limiter, right? So in the plus one, the answer is minus 50 kilojoule. So this is how energetic values are given. Right? This one we call exothermic. Exothermic reaction. Exothermic. So we can use. This particular value we call endo. This is how the positive and negative values comes to the decay. Okay, and if you have any issues, you can speak. Right. So now we spend a lot of time here. Right. For group 1, the one is a negative. Exothermic. Any energy. That is position of nitrogen is found somewhere here. The region there. The phase of beryllium means second group, group 2. Group 2 will form here beryllium, magnesium, the values equally 4. The answer right? They are asking, right? Liberate largest amount of heat, exothermic, largest amount of energy. Which one is largest amount, right? If you have the element, what is here, in bottom area, the element that will be the answer, right? We see value for sodium, yeah, right? Sodium is somewhere here, isn't it? Sodium is the position. Then argon, yes, it is once again come in the positive region. Helium, neon, argon above magnesium and calcium. Beryllium, magnesium above high positive value. It won't come. Lithium, yes, it is here, right? It is here. Lithium, the value more energy in it compared to sodium. Sodium compared to sodium, lithium liberate large amount of energy. Yes, sodium and lithium compared to lithium is the answer. Okay. Nitrogen, positive value. Can't be the answer. Magnesium, that also positive value. Can't be the answer. So definitely negative value of lithium or sodium. But if you compare these two, right? Sodium and the lithium and the liberate large amount of heat, and it is very clear. First, so answer is lithium. Lithium is the answer. I think you may put the answers. Okay, let's go to if you have an issue, you can speak. You can chat with me if you have any other. Okay, what is this? Which of the following molecule is non-polar? Non-polar actually this belongs to second unit. Second unit non-polar polarity, comparison of polarity, second unit of last session. Mean secondary interaction in the topic it will come. Very basic idea is non-polar. If there is electronegative difference, then we'll have a polarity, right? Count from the for this particular purpose, find the polarity, you need a molecular shape, right? Beryllium chloride. This way you can draw the molecular structure can be drawn, isn't it? Ammonia, yeah, you can draw in this way, right? You can draw the shape of ammonia. Carbon monoxide, I think you may be able to draw the Lewis structure clearly. Water molecule in this way, isn't it? Okay, and finally, fluoroform, CH3. These are the structures. To find the polarity, right? Molecule, if it is polar, right? You need the Lewis structures. Lewis structure, molecular shapes needed. Molecular geometrical shapes are needed. Class only right. Sometimes you may not learn, right? You may not learn. Clear here we call dipole moment. Dipole moment and we learn this is zero. Why? Attraction toward chlorine, right? Both sides the same magnitude. Therefore, the net values become zero. This is we call dipole moment. That is zero. Here, right toward nitrogen, there is attraction, right? So there is a net attraction is there, upward movement is there. Therefore, there is a value, right? It's non-polar, it's polar molecule. Then the lane toward oxygen, right? There is attraction, right? Here also attraction toward oxygen, there is a net value. This way net value. Right, if 3 atoms are or 4 atoms are similar, this non-polar, right? One of this is different. One of this is different, therefore, this is polar. The 4 atoms are equal no problem. Okay, okay, you can understand. So the answer, what you said is correct. The answer is beryllium chloride. Beryllium chloride is the answer, right? Okay, let's move to the question number 4. Right. X, Y, X, W, X, Y, Z are 4 non-transition element. Non-transition means it is not a D block element. I think you may know this block. D block, D block. Big P, between S and P, there is a block we call 10 elements piston region. We call transition element. These are not a transition element or D block element information. Non-transition can be either S block or D block. That is the message. With consecutive atomic numbers adjacent in one of the other, that is the consecutive atomic numbers. It can be right one group element or one period, right? Starting from lithium to neon or right consecutive mean right, for example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, here neon and sodium. Consecutive right, starting from fluorine, oxygen, neon and sodium continue right? 2 periods may be included, considered together. We'll see what it is. So consecutive atomic numbers. The first ionization enthalpy of W, X, and Y are the only 3 are provided. Only 3 are provided, but it is right gradually increases. We'll see plot a graph and see how to understand this issue. Right. This is a graph I have just prepared for you. This is lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, and neon. And this one sodium and magnesium. So consecutive mean I told you, consecutive where you have to be very careful, right? Sometime 3 order, 3 over. And the fluorine, fluorine, neon, sodium, magnesium, this is a consecutive equal, right? You have to understand this kind of things, right? Okay. We have 2 places actually. WXY, W, X the value X Y the value. In this way, they have given the only information given. So that sort of answer can come in two places. This one place, this I'll try to mark it as the one place, X, Y, Z. This is another answer. So these are the two places where X, Y, Z can be considered. In the W R and the X R and the this can be Y or these three W, X, and Y, right? So we need certain information, right? Is it boron, carbon, nitrogen, or oxygen, fluorine, neon under the confirm bundle? We still need data, right? We'll see what it is. They have provided information related to Z. Silly. Z is a diatomic. Silly. That is a diatomic molecule. Diatomic molecule information they have provided. Okay, now let's check it. Right. The Z in either it should be an oxygen, right? Or it has to be sodium. Right? Meaning that Z is a diatomic molecule most suitable for the oxygen. Most suitable for the oxygen. It is in the room temperature, or to exist. But remember that even sodium also may become Na2. Diatomic molecule extra not in most suitable answer compared to oxygen and Na2. This should be the most suitable answer, right? Sometimes they may argue to give this one also, but I think it is preferred to give the oxygen answer. Suitable answer is also, but it is possible. There is a possibility in different conditions. You can have a sodium even as a diatomic molecule, right? Okay, let's come to the question part. Okay, the electron configuration of outermost shell of Z, then oxygen. The answer is NS2, N4, NP4. I think we can clearly understand the work, right? Okay, let's move to the next level. Right. Actually, I need a little bit information about you. Can you type your names quickly? Chatla konjam neenga names type பண்ணுங்க for conveniently I can understand what people take part in the session. Quick konjam type பண்ணுங்க உங்க names. Right. Okay, which is the smallest ion out of the following ions in the gaseous state? Okay, smallest one, right? Actually, we have a clear picture. Cations are smaller than that of anions, right? So, cations smaller than the liquid. There are two cations, right? If you consider the configuration, all are same. So, we call isoelectronic. Isoelectronic. Right, electron configuration of anion if we consider, we call isoelectronic, right? But only the proton numbers are different, right? Here 8 proton, 9 proton, 11 proton, 12 proton, then this one 7 proton. This one attracts much more powerfully the electron cloud. So smallest ion, the cations are usually smaller than the anions, right? It's very clear. This attraction is more powerful. Okay, let's move. The question number 6. Which of the following statement is correct regarding the atomic spectrum, emission spectrum of hydrogen? That's the question I'm putting. Okay. Actually, I didn't change anything. Right, just okay. Right. In the next session, I may prepare a Google sheet, or I'll try to prepare a Google sheet, exam paper worksheet. Now we can understand how much you learn the content powerfully in next and rather than in hard copy. Can provide that sort of thing, right? Okay, which of the following statement is correct regarding the atomic emission spectrum of hydrogen, right? Understand the radiation corresponded to the N is equal to 2. So N is equal to 1 transition. That's the largest energy. What do you mean by? Right? 2 to 1, if you do this, this one N is equal to 1, 2, 3, 4, right? Issue we have to speak, right? Counting it. Yeah. Can you speak?
So for fifth question,
Left to right, the size decreases, right? Only 1 minute we have. For 1 second, the size decreases.